Okay, time to look at the mach3 settings. Come up here to the ports and pins. Now here I didn't have to do anything. It was already, I am using a parallel cable on an old computer, and this was the correct settings right off the bat. I did play with the kernel speed, and the higher I went with it, the faster I could make the CNC go. This is back when I had a 36 volt power supply, and I couldn't get it to go fast enough. And as I raised the kernel speed, it did go quicker, but it was less reliable. And once I upgraded to the 60 volts, I dropped down to 25. I may play with that again in the future, I don't know. Motor inputs. I have the X, Y, Z, and A axis enabled, and the spindle. There's my pin, my X axis step pin. Let's see if on the video might be able to make it out. I don't know, but I'll read it. X axis enabled, step pin 2, direction pin 3, direction low active, or whatever that is, DIR low active is X off, or it's saying it's high active. Step low active is negative, it's high active. All the port pins are going to be 1. So for the step and direction, both they're going to be 1. All right, then we start to the Y axis, and it is enabled. It is on step pin 4, direction pin 5, and the direction and step are high active. The Z axis is enabled. Step pin is 6, direction pin is 7, and both of the direction and steps are high active. A axis is enabled. It is step pin 8 and direction pin 9, and these correspond with the pins on the breakout board. And on the A axis, the direction and step active are high. And then we do nothing with the B or C axis. We get down to the spindle. It's enabled. Step pin 1, direction pin 0. Direction and step are low active. So that's the motor inputs. Input signals. We are using the limit switches and the E-stop at this point. So if we come up to the limit switches, you got the, on all of them I have the plus and the minus enabled, and the home not enabled, disabled. All port pins are 1, and for the X is pin number 12, the Y pin number is 13, the Z pin number is 15. All active low is negative. They are all active high. Emulated are all red X, and hotkeys nothing. If we come down to the emergency stop, it's enabled. It's port 1, of course, pin number 10. And low active, it's not low active, it's high active, and not emulated, no hotkey. So now we're going to go to output signals. Output signals, what we got? I guess we've got the for the spindle control. I think this is what goes over to the VFD, and that's the pin 14 for the enable 1 is enabled, and port 1 pin number 14 active high, not low. And then on the output number 1, it is enabled, port 1 of course, pin 17 and it's high enabled, not low. That is it on this page. But I'm pretty sure what that does is it takes the information out of the breakout board over to the VFD. Then we go to the encoder, MPGs. I don't think there's anything on here we did. Spindles setup. Seems like there was something here. Nothing's ringing a bell. I don't see anything. So we'll forget it for now. And that's, I don't remember doing anything here either. So that's what I did on that one. And let's see, general config. Is there anything I did here? No, I don't think so. Native units, yeah, you do that when you first start. Homing limits. I did do a slave axis for the A axis. X axis, no slave. Y axis is slave to the A axis, or vice versa. I don't know how they look at that, but Z axis, none. So I did do that. And let's see. Save settings, safety setup. I don't think I've done anything else. Motor tuning. I've got it set. What you do when you're motor tuning is you play with the the steps per unit is not something you want to mess with. You calculate that for your whatever lead screw you have or whatever you're using, and that is what it is. But then the velocity and acceleration is what you play with here to get your how well your steppers will perform. And you can see I've got about a 0.25 millisecond or 0.25 seconds, 250 milliseconds response time. It's maybe, yeah, it's about 0.2.5. I called somebody at Legacy one time for my other machine, and they said 0.5 is what they shoot for. So I'm doing a little quicker response than what they call for. I think in my mind I should stay within somewhere between 2.5 and 0.5. 0.2.5 and 0.5 is where you want this first to come out. And that's how fast it's supposed to take to get to full speed. So like for example, if I went to 4 on the acceleration, and see it's gonna have a slower acceleration and it's gonna take longer to get there. So now it's taking 0.31, 0.32 to get to full speed. And I do 3D work, so I try to get real quick response. Now the quicker you get that to get there, that's like a bigger jump, bigger jolt. So that's going to be harder on the steppers, and that's going to reduce the speed you can get reliably. Like if you set this thing at 1, look how much time you've got. You got over a second, almost a second and a half before it gets to full speed, and that's a long time. So because it's easing in and easing out, you could get a higher top speed. But if you're doing 3D and you don't tell it to stop at the end of every move, it'll basically what it does is as soon as 2 axes are there, it just goes ahead and starts the next one, even though the last one's not there. So a lot of times the Z axis won't quite be there, and it'll just slur. It'll make it won't be crisp, put it that way. So I work with 2 to 3 is what I like. I have worked at 0.5 for a long time with the Legacy CNC, and it's okay. But by going to 2.5, I have to lower my top velocity. And that's, and if I didn't, I'd be losing steps. So this is where you go. If you're losing steps, you have to slow down your velocity or slow down your acceleration, or both. You got to find the right match for what you're doing. And if you're just doing 2.5D work, you can go with a pretty slow acceleration and you can get a better velocity. So that's what there is about that. That's the motor setup, motor tuning, I mean. That's pretty much it. I can't think of anything else. So there it's documented. Thanks a lot.